Hi, I'm Memorise, the chemistry guru, and you are watching H2 ChemHacks, making H2 chemistry simpler, one video at a time. Hi, in this video we'll go through the reactions of alcohols as well as their reagents and conditions. Now altogether we have 4 preparation reactions and 6 reactions involving alcohols. So let's take a look at all these reactions. Now the first preparation reaction is the electrophilic addition of alkenes to give us an alcohol. Now what's the reagents and conditions for this conversion? Now there are 2 ways for us to do this conversion. The first one is concentrated H2SO4 followed by water heat. The second one is steam in concentrated H3PO4 at 350 degrees Celsius, 70 atmosphere. So this conversion is done either by using concentrated H2SO4 followed by water heat or steam, con H3PO4, 350 degrees Celsius, 70 atmosphere. Now the second preparation reaction involves the nucleophilic substitution of our halogenous alkane to an alcohol. So what's the reagents and conditions for this conversion? NaOH equals reflux. So again, this conversion is done via NaOH equals reflux. Now the third preparation reaction involves the reduction of carboxylic acid to our primary alcohol. So what's the reagents and conditions for this conversion? Lithium aluminum hydride in dry ether followed by water. So this conversion is done via lithium aluminum hydride dry ether followed by water. Now take note, when we reduce our carboxylic acid, we can only get a primary alcohol. Now the fourth preparation reaction involves the reduction of our carbonyl compounds to give us our primary and secondary alcohols. Now if you have an aldehyde, I can reduce the aldehyde to primary alcohol. If I have ketone, I can reduce this ketone to secondary alcohol. So what's the reagents and conditions for this conversion? I have 3 reducing agents that we can use. We can use hydrogen in platinum catalyst heat. We can use lithium aluminum hydride in dry ether followed by water. I can also use NaBH4 equals at room temperature. Okay, so this conversion can be done via any of these 3 reducing agents. I can use hydrogen in platinum catalyst heat. I can use lithium aluminum hydride in dry ether followed by water. I can also use NaBH4 equals at room temperature to convert our carbonyl compounds to alcohols. Okay, next let us move on to the reactions of alcohols. Altogether we have 6 reactions that we want to talk about. Now the first reaction is our elimination reaction of water from alcohol to give us our alkene. So what's the reagents and conditions for this conversion? Now I have 2 reagents and conditions for us to use. The first one is con H2SO4 at 170 degrees Celsius. The second one I can use is aluminum oxide heat. So this elimination reaction is done via con H2SO4 at 170 degrees Celsius or aluminum oxide heat. Now the second reaction is the nucleophilic substitution of our OH group to our halogen functional group. So we are converting an alcohol to a halogenal alkane. So what's the reagents and conditions for this conversion? Now depending on which halogen that you are substituting, now if you want to substitute Cl, then what we use is we use PCl5 or SOCl2 anhydrous at room temperature. Now if you are substituting bromine, then the reagents and conditions will be HBr or PBr3 warm. So again, this is the reagents and conditions for the nucleophilic substitution of our OH group to our halogen. If you are substituting chlorine, then we use PCl5 or SOCl2 anhydrous, room temperature. If I'm substituting bromine, then I'm using HBr, PBr3 warm. Now the third reaction involves the control oxidation of our primary alcohol to our aldehyde functional group. Now, take note, only primary alcohols can be oxidized to give me our aldehyde. So, what's the reagents and conditions for this conversion? Now, because it's a controlled oxidation, so we can only use K2Cr2O7, dilute H2SO4, reflux with immediate distillation. So, this controlled oxidation is done via K2Cr2O7, dilute H2SO4, reflux with immediate distillation. Now, take note, if you use KMnO4, you oxidize my primary alcohol all the way to an acid functional group. If you don't do distillation, same thing, your primary alcohol will be oxidized all the way to a carboxylic acid. Now reaction number 4 is the oxidation of alcohols to give us carboxylic acids and ketones. Now, a primary alcohol will be oxidized to carboxylic acid, while a secondary alcohol will be oxidized to ketone. So what's the reagents and conditions for this conversion? Now we can either use KMnO4 or K2Cr2O7 in WH2SO4, heat or reflux. So the oxidation of primary alcohol to carboxylic acid and oxidation of secondary alcohol to ketones is done via KMnO4 or K2Cr2O7 WH2SO4 reflux. Now reaction number 5 involves the acid-base reaction of our OH functional group to form our O- Na+. So what's the reagents and conditions for this conversion? Sodium metal at room temperature. So this conversion is done via sodium metal at room temperature. Now the last reaction that we're going to talk about is the esterification or the condensation reaction between alcohol and carboxylic acid. So in this case, this is my ester functional group form. So what's the reagents and conditions for this conversion? Now there are two ways for us to do this conversion. The first one is to use acid with con H2SO4 reflux. The second one is to use the acid chloride at room temperature. So this condensation reaction or esterification can be done either by using our acid RCOH in con H2SO4 reflux, or I use my acid chloride RC double bond O bonded to Cl group at room temperature. Okay, so that's all the reactions that we have for alcohols. Now remember, altogether we have 4 preparation reactions and 6 reactions of alcohols that we have to be familiar with. So hopefully by watching this video, it helps you remember the reagents and conditions a little bit more easily. Now remember, we have to be familiar with all these reactions because this is fundamental in organic chem. If you don't have any concepts in terms of the reagents and conditions and all the reactions that are possible for a particular functional group, then you will not be able to answer questions in organic chem. I hope you enjoyed this video. Please give me the thumbs up, like this video, and share this with your friends. For more awesome JC H2 Chemistry video lessons, please subscribe to my YouTube channel. If you have any feedback, questions, and suggestions to new video lessons, please drop them at the comment section. I'm also conducting JC H2 Chemistry classes at Bishan Central. Please visit my website for more information. Thank you for watching H2ChemHacks. I'll see you next time.